Welcome to Spring LIB.
So we're asked here to look at the reactivity of metals, some different, mainly transition metals and aluminum here with some acids, both strong and um, both concentrated and dilute solutions of acids. So manganese is the first example, reacting with the dilute sulfuric acid. And first we're asked to write a molecular overall reaction for this process. So it's going to produce for us manganese sulfate, where manganese will take on a +2 charge, and it will release hydrogen gas also in the process. So um, overall, these are the products that we're going to get from this reaction, and this would be a molecular equation for the reaction. We're also asked to represent this as an ionic equation, and so as an ionic equation, we would show the separation of the sulfuric acid into hydrogen ions and sulfate ions, first present as a reactant here. And then as a product, the manganese would become manganese 2 plus. The sulfate ion would essentially behave as a spectator ion here. So if this were a net reaction, we would simply ignore the sulfate components and then show the production here of hydrogen gas. And so the net reaction would simply show manganese as a net ionic equation, manganese reacting with hydrogen ions to produce a manganese +2 cation and releasing hydrogen gas. The next reaction is between chromium and concentrated hydrobromic acid. And first, we're asked again to depict this reaction as a molecular reaction. And so we have overall a chromium 3 bromide that would be the likely product of this reaction, and also releasing hydrogen gas again, as in the previous example. So, as a molecular reaction, we'd have two solid chromiums reacting with 6 hydrobromic acids to produce 2 chromium 3 bromides and releasing 3 hydrogen gas. 3 moles of hydrogen gas along the way. And this would be the balanced molecular reaction. The net reaction would be showing chromium as a solid, and then the hydrogen and bromide ions existing separately in an aqueous solution, and the chromium ions existing separate from the bromide ions as products, where that hydrogen gas is still evolved as a product. But notice here the bromide ions are just spectator ions. And so they would not be included in the net ionic equation, and we'd end up with 2 chromium solids, 6 hydrogen ions, the 3 moles of hydrogen gas being emitted, and just the 2 chromium 3 plus cations as a product. The next reaction shows tin reacting with hydrochloric acid, and that's likely to form, for the most part, a tin 2 plus um, cation, so tin 2 chloride, and again evolving hydrogen gas as a product. And this would be the balanced molecular reaction. So let's look at, this time we're just going to write the net ionic reaction instead of crossing out the spectator ions. We're just going to ignore them and write the net ionic equation. So the net ionic equation will again ignore the spectator ions, which are the chloride ions here. We'd have solid tin reacting with 2 hydrogen cations. I'm just going to rewrite that 2 to make it clearer, to form a tin 2 plus cation primarily, and evolving hydrogen gas as a product. And there's our net ionic equation. One final example here is aluminum reacting with formic acid. So I just kind of rewrote it to make it a little clearer here. But this would be the balanced molecular reaction. We're going to have, actually, hold on just a second here, because that doesn't depict it correctly. Okay, that's better. Knew something was wrong. So the aluminum formate, aluminum is going to form a +3 charge and require three formates with a -1 charge to balance that. And so we end up with this balanced overall molecular reaction where we have two aluminums, six formic acids to produce two aluminum formates with this formula and evolve hydrogen gas again as a product of the reaction. Now let's write that as a net ionic reaction. So as a net ionic equation will look like this, where you have two aluminums combining with six protons to produce two aluminum 3 plus cations and evolving 3 moles of hydrogen gas, where the formate ion here is the spectator ion, and that will be ignored in the process.